you should have already had some sort of touch points with OLX, but I'm going to ask who here, and show of hands now, has either sold something or bought something using OLX. Hands up. Okay, so we have a good crowd. But then another question: who tried or who actually succeeded to buy an apartment or rent an apartment using Autodom in Poland? All right, cool. Good show of hands. And the last one, or maybe we'll do two more. Who has tried to buy or bought a car using Automoto? Okay, that's a good show of hands too. And the last one, descending order, you can see, who maybe had something fixed or a service done for them using Fixly. Nice. All right, cool. All these 4 products are being developed here in Poznan and in a few other PDT, we call it PDT, it's basically tech hubs around Europe that OLX is working from. Not only Poznan, but also places like Lisbon, which is our second main site for engineering. We also do some development in Berlin, Barcelona, Bucharest, etc. We're happy to host you here. In terms of front-end work, because front-end is at the very heart of what we do have plenty of front-end being done at OLX in different units. Happy to talk to you about the front-end work we do. One last show of hands: who's a front-end developer at OLX today and is here in the room? So keep your hands up. Everybody that is not from OLX, look at these people and please, during the breaks, just ask them questions, because we do very cool things. Yeah, we do have exciting things to share from OLX today. Both Johnny and Daniel, who are going to be presenting today, are from OLX, and they're going to be talking about cool stuff we do. But additionally to that, we also have one more presentation from Aleksandra in the middle, and we are going to do 2 presentations, then we're going to do a short coffee break, another presentation at the end, and then we will go into well, fun stuff, so networking, food, drinks, etc. And without further ado, I would like to welcome on stage our first speaker, Mateusz Hajdziony. He goes by Johnny and OLX. Big round of applause. And I will introduce you to Johnny a little bit better. Johnny has been a front-end engineer since 2008, specializes in React-based front-end system architecture, currently is a senior front-end engineer at OLX working in front-end platform team. Lots of responsibilities, leading the way to micro-front-end modularization of our platform. So, stage is yours.
Okay, we have a Zoom setup, so let me quickly connect to Zoom. Sorry for this delay. Right, let's start. So hello everyone and welcome to the very first presentation of today's evening. The title is going to be Module Federation in Practice, a deep dive. But before we dive deep, let me quickly introduce myself. So my name is Mateusz Hajdziony. I'm a front-end engineer working in front-end platform team. As Bart said previously, for OLX. I am a first-time speaker, at least first time, for a live audience, so please forgive me any mistakes that I might make. I am super nervous if it doesn't show yet. Today's agenda is going to be Module Federation and the evergreen nature of its remit. So we are going to go through a very quick recap of what Module Federation is and how it works, how the insight of Module Federation works at some point. Then we're going to cover some basic puzzle pieces which I think that you should think about or implement if you want to run a successful Module Federation implementation. And then we'll quickly close up with some quick takeaways. So without further ado, what is Module Federation? And this is an excerpt. Hope that you can all see the small letters here. I'm going to read it. It is an excerpt from modulefederation.io website, and it reads that with Module Federation, code can be split into smaller, independently deployable modules that can be loaded on demand when they are needed. This allows micro frontends to be developed and deployed independently, which reduces coordination between teams and allows for faster development cycles. So usually Module Federation promises to solve some common pain points that we usually have with big monolithic code bases on the front-end side of things. How it usually works in practice is that you are going to have this kind of host application, so it is going to be your entry point where the actual website that your users visit, the host application is going to take care of all the like shared stuff on the website. So it's going to provide a shell for other modules to load, probably some common components like header navigation, footer, etc. And also some basic state sharing or sharing of some basic functionalities. Then we're going to have a bunch of micro frontends, and in Module Federation world they are called remotes. So remotes are nothing else but a collections of JavaScript files, JavaScript modules, which come from a different and completely independent Webpack build. So usually those JavaScript bundles, they are deployed to something like an S3 bucket or a similar technology, so you do not need any complex architecture to run this kind of micro frontend setup. Then the host application, whenever it feels like so, whenever it needs, whenever the user wants to visit a particular part of your website, the host application is going to on demand load, access one of those remotes, one of those modules. Then Webpack is going to resolve all the shared dependencies and that are required by all those modules, and then compiles a cohesive application of it. I'm not sure if you can see it here, but every single remote application is going to have like its regular JavaScript chunks, but also it is going to have a file called remote entry. So this remote entry, it's an entry point to your application. It's a kind of manifest of what your micro frontend actually exposes to the world, and then it is a manifest of all the dependencies that the micro frontend requires to run. So by design, those remote entry files, they are going to be unversioned, which means that they are evergreen, or at least I call it an evergreen. So this is where the evergreen nature of Module Federation comes from, is that whenever the remote is requested, it is always going to serve the very fresh version of whatever is deployed on your S3 bucket. And also, so that's also why you do not ever want to cache those remote entry files, or if you want to cache them, then just go with something like a minute or two. So we have a theory. So I've actually prepared. They said that don't do live demos, but I didn't listen. So what we have here is we have a very basic Module Federation application. So you can see that I have my host application. As promised, I have two remotes, remote 1 and remote 2. So immediately what you will notice is that every single one of those remote applications, they are basically self-contained JavaScript applications with their own build folders, build scripts, configuration files, and package.json where they define all their dependencies. The same goes for the host application. So now where the entire logic happens actually is in this Module Federation config. So the remotes, they are going to say that they expose modules to the outside world, and so these are actually the modules that can be consumed from the remote. And then the situation is quite similar, but a little bit different in the host application. So the host application, instead of exposing anything to the outside world, it is going to say that it is going to consume those remotes, and here is where we tell Webpack where those modules are, and then where Webpack can find them whenever they are loaded, wherever the host application wants to do it, but this happens all in runtime. So this part is very important, because if we now go to our actual React application that we have, you can immediately notice that we have those lazy imports here, and we are trying to import stuff from remotes. But as you know, remotes come from separate build processes in Webpack. So whenever Webpack sees that you want to import something like this, it is going to substitute this import with a piece of runtime code, and this piece of runtime code knows how to load and where to find your remote and how to resolve all their dependencies. So then, what else do we have? We have a basic user state in our application. Then, as promised, we have this application shell, so the basic HTML structure, and then we have some common components. So in my case, it's navigation, routing, and then my host application is going to define a bunch of routes. So the first route is going to be our homepage, and I'm saying that my homepage is going to be handled by a local component. The situation is quite different in case of routes 2 and 3, because I am telling my application that I want those to be handled by those components which are loaded from remote. Now, as to my local development environments, what I'm doing here is I'm basically running 3 Webpack dev servers. They're running in parallel, but you can extrapolate my setup to your actual setup with CI/CD pipelines. So whenever I save a file, you might imagine that I would just open a merge request, then go through my usual build process on my CI/CD pipeline, which would build this specific module and then deploy it to either a server or an S3 bucket. And then also, as premised, let's see where the network federation power comes from. So here I am in my host application. I'm going to say hello, for example, user.name. I'm going to save the file, rebuild, redeploy. Well, and I forgot to show you the actual application, how it looks like, but you can see already that we have our changes in production. So then also, what else do we have in this application is we have our route number 1, which is handled by the remote 1, and route number 2, which is handled by remote 2. Going back to the power of module federation, I have shown you how you can update your host application. Now let's jump in quickly to this remote application. So currently, yeah, you have seen this content on the actual website. I'm going to say that I want to add something else and tell the user what their ID is. So your user ID is user.id. And I'm going to save this, and you can see that only the remote application 1 has been actually rebuilt and redeployed. But when I refresh my website right now, you can already see that the changes are live in production. So this is independent development, independent deployment. So you can build only your remote module, and you do not have to rebuild anything else. You do not have to touch the host in any way, but your changes are live on production. So this is also usually where usual online tutorials or YouTube videos or sometimes even conference talks, this is where they usually end. And if you are like me, you are going to have some questions like how do we work with this kind of setup in practice? So the first thing that you have to answer or maybe ask yourself, how do I actually want to split my code base? So my advice here is that you want to avoid too much fragmentation as much as possible. So of course we are fragmenting our code base, but like we do not want to end up with 68 or 150 separate small modules. So we want to extract as big chunks as possible. So I advise you to go with monorepo. I would like to talk a little bit more about that, but we don't have too much time, so just take this as a starting point advice. So whenever possible, just use monorepo. Whenever possible, split your application route by route. So something that I have done in my demo, where you have those big sub-applications which handle entire routes. And this is what we call a vertical split of the application. And then we also have to be ready that you will have to establish clear guidelines as to what is eligible to be a separate micro frontend in your project or in your company. So now that you know the very basics, we have set up our split of the application. Let's see how this setup is going to break, because this is the most important part of developing stuff. Is you always have to see where it breaks to be able to properly decide if you should even use it. So then this was my remote application 1. I'm now going to go to my remote application 2, because I am remote application 2 developer, and then I'm going to say, hey, I want to have the same stuff that people from remote 1 had. So I want to have a user passed to me via props, and I am going to say that I want to do this hello user.name. I'm going to save my application, rebuild it, republish, and then visit our production refresh, and we have broken production. So why did this happen? Yeah, obviously it happened because we have introduced a breaking change. The breaking change being that we have changed our the contact or the API of our remote without notifying the host application first, which obviously doesn't pass the user object here at all. So how do we deal with issues like this? So usually what you want to do is you want to avoid breaking changes as much as possible. So you can use one of several flows. Sorry if this is too small, I'm going to tell you what's there. So the first flow that you can use is where you update the host application first, and you provide all the properties to your React components first, and then and only then start working on your remote. But this is going to require some planning ahead. So now, if you are not yet sure what is what your remote actually requires, what you can do is you can opt in for this flow where you define our properties as optionals first, then deal with them with this optional way. Then once you have the API kind of under control, we'll then start changing the host application to provide all the properties required, and then go through a third step, and this is where you clean up your micro application and remove all the optionals. But as we all know, it's like the world is not always perfect. We are going to inevitably at some point have to do a change which introduces breaking changes in our remote applications, and for this we will have to break away from this independent and evergreen flow of things in Model Federation, and we will have to introduce hard versioning to our system. So hard versioning is it's not hard to do. So basically you would have to modify your deployment scripts, and instead of just constantly deploying to the same S3 bucket, you would basically take the, for example, version parameter from your package.json file and then deploy to, for example, a subfolder on the S3 bucket, and you have created a new subversion. So whenever you do this kind of subversioning, until the host application actually switches the remote that it wants to consume, it is going to consume the old one. So this is how you deploy new breaking changes. Oops, sorry. So then most of the changes that you do are going to be internal to your micro frontend. So like 99.9% of your merge requests are going to be completely independent. You will be able to deploy stuff completely independently, but you have to be ready for those rare cases where you actually need to change the API, where you actually have to introduce a breaking change, and for this you will need to build some additional tooling or at least some modifications into a deployment flow to also take into account this hard versioning process. So now, are we safe? Is this all? And the simple answer is that not yet. We still have some ways to go in order to make our application safe and to prevent us or our developers from breaking the website accidentally. So I have created yet another demo. So it's very similar to the previous one, but I have made a simple change in my remote tool. So now my remote tool, it expects there to be this user ID property passed from the host application, and I expect this property to be a string, and I am also performing string manipulations inside my application. And yeah, everything's fine. Let's see if this is working. Yeah, it's working. Remote 1 is working, remote 2 is working as well. That's amazing. But then, let's imagine that I am a developer who owns this user data, user context. I am from a separate team. I don't know those guys from the remote 2 team. And one day I wake up and I choose violence. I decide that the user ID should not be string. It is now going to be a number. So immediately when I change the type here, you can immediately see that the TypeScript compiler starts complaining and says, hey, like, yeah, this ID shouldn't be a string, it should be a number. So then I assign like those default values. I'm going to say that the user ID is something like this. TypeScript compiler is happy, I am happy as well. I will build the application, deploy it to production, and again we have broken production. So now, like obviously, user ID.replace is not a function because numbers do not have this replace method on them. So then why was I able to deploy my application in the first place? Well, there is a very simple reason for that, is that those modules, they are remote, which means that TypeScript compiler knows nothing about them. So TypeScript compiler cannot even reason about your modules to tell you that there was some kind of breaking change introduced and you are now passing wrong types of values here. And actually, in order for me to be able to even use those like remote components as actual React components, what I had to do is I had to hack TypeScript compiler into thinking that they are actually, that there is anything hiding behind them. And this is usually what you will see in any like basic online article whenever or where you ask a question, for example, on Stack Overflow, and ask, hey guys, how do I run module federation with types? And they are going to tell you, hey, you have to do this custom declarations file where you say that your remotes are basically React components which accept any random property that we throw at it. But if I were to remove this like hacky piece of code and save the application, you can immediately see that TypeScript doesn't understand what it is at all, because this is remote. So now, how do we fix this situation? Well, we introduce something like contracts. So because like in the end, the remote is going to define a contract, and then the host application which wants to work with this remote, it has to adhere to this contract. So what we have built in our case, like the ways of introducing those contracts might be vastly different. There are plugins which are going to help you with that. Basically, what you need to do is you need to, every time you make any updates to one of your remote applications, you are going to have to extract the actual types of your remote components and then somehow deliver them to the host application. So in our specific case, we have built a custom tool for extracting those types, but you could opt in to use a ready-made plugin for that. So basically, TypeScript compiler is your friend. It can create those kind of contract file for you. So as you can see right now, I have two definitions because I run two microfrontends. I have two definitions of remote applications, and again, we declare that there is remote application. It's a React component, but this time it accepts, or it wants to have very specific types of properties. There is one small step that I still need to do, is I need to tell TypeScript compiler to actually read those contract files. And yeah, we have been able to bring the types. You can actually see that my remote up to is now correctly typed as accepting only user ID, which is only a string, not a number. So such applications wouldn't compile at all, and I wouldn't be able to do this kind of change of user ID from a string to number. I would have to either, for example, translate this number to a string, or maybe talk with the guys that own the application to release my version, whatever. So now, creating those contract files, this is easy, but then how do we actually work with those contract files, and how do we make sure that they are respected? So we have opted to do this in our CI/CD setup. So this is a three-step operation. So okay. So the first step is going to be, whenever there are changes in any of the remote modules, we run a contract validation step for this specific module. So the contract validation step is going to generate the contract on the fly, and it is going to compare it with the version of contract that has been committed by the user in a merge request. And then if those files are exactly the same, we know that the contract hasn't changed. We can proceed with the pipeline. But whenever there are any changes, any small change in the contract file, we fail the pipeline, and we inform the developer that they have to regenerate the contract file. Now, the second step is whenever there are changes in the contract folder, what we do then is we are going to run a contract validation CI/CD job for the host. And in our case, we are basically running TypeScript compiler against the host application. And again, we are checking, are there any TypeScript errors? Yeah, if there are any TypeScript errors, this means that you are now breaching the contract, that that there has been a breaking change deployed and we are failing the pipeline. If there are no errors, and there are cases when you can change the contract file, but there are not going to be errors. It's just that you are now properly extending the types and there were no breaking changes. If there are no TypeScript errors during this step, we continue the pipeline and we are fine. And the last piece that we have to care about is whenever there are changes again in the host application, we would usually build our host. We build our host with TypeScript. So again, are there any TypeScript errors? If no, then we continue the pipeline. We know that the changes that you have made to your host application are compatible with whatever is in whatever your remotes require. Again, if there are any TypeScript errors, then we fail the pipeline because it is either you who have breached the contract or the owners of the remote module. So, yeah, we are now sure we are using TypeScript and this auto generation of contracts and all those ifs on our pipelines, and we are sure that the changes that we are deploying either in the host application or the remote application are going to be compatible with each other, and that every single piece of your system is going to adhere to the contract. So the next issue that we are quickly going to run into is an issue with bloated properties. So after 6 months or a year of when your product is going to grow, your code base is going to grow, your microfrontends are going to require more and more properties from your host application, so you will end up with this kind of mess where you are expecting there to be like 50 or 60 like properties, and from experience I can tell you that people are going to be passing anything through those. For example, an entire React components through properties, just because they have no other option to do anything else, because the properties, component properties, are the only point of contact, at least for this moment, between the host application and your micro frontend. So then, how do we deal with this kind of problems? And the answer is simple. Simple in theory, harder in practice is that we have to introduce libraries or private packages, where we in those libraries what we can do is we can extract some functions, components, shared state via React context or something else. We can extract those kinds of functionalities into smaller self-contained libraries and then publish them in our repository. We use Meta repos, so we have all those libraries, we keep them in the repository. What you want to do here is you want to extract the core functionality only. So again, you want to avoid fragmentation as much as possible. So only extract those that you actually have to share between all or most of your frontend. So extract core functionality only. Another advice is that you should probably extract the code which is already well established. So if you have a piece of code functionality which is constantly evolving, this means that you would constantly have to redeploy new versions of your libraries, and dealing with versioning again is going to introduce a lot of friction points where you have to constantly update all your micro apps to the new versions, etc., etc. So once you are sure that the piece of code is well established, you then go and extract it as a library. Obviously, you publish those libraries to your private registry. We use GitLab, so GitLab provides us with this kind of functionality, but any private registry will do. So examples of libraries that you might probably start extracting right off the bat is like your utility functions, utility components, authentication, user state, internationalization, and things like that. So now that we have covered some of our bases, we know that we ourselves are at least from the TypeScript perspective, and we know that no one is going to accidentally break our production. We have our code organized in libraries. So then, what are the key takeaways that I would like you to remember from this presentation? And the first takeaway is that there are seemingly small things which are going to have big implications to how you interact with your code bases in the future. So we have seen how including Web1, relatively simple plugin into our architecture is going to completely change the way that we work and that developers in our company are going to interact with the code base in the future. Micro-frontends are complex, so we have only scratched the surface really here. The must-have tooling that I think that is absolutely necessary to run any kind of successful micro-frontend implementation. Well, first you have to establish your repository structure, so go with monorepo all the way unless you specifically need to. You will have to develop a splitting strategy and write clear guidelines about that. You have to introduce versioning to your system. You need to develop those contracts, and there are still things that we haven't even touched yet. So, for example, you need to think about dynamic remote module injection. You need to think about how you are going to end-to-end test your applications, because you cannot test a small piece of your application because your users, in the end, they are going to use your application as if it was a monolith. So you need to be able to end-to-end test your users from start to finish. And then how do you share dependencies between modules, and then how do you update those dependencies? Because, for example, if you are using, 50 or 100 of third-party modules, which are again used and shared between all your micro-frontends, you will at some point have to build or use some kind of tooling which is going to help you update and keep all those dependencies in sync. Now, should you use module federation? I cannot answer this question really, but I can give you some rough guidelines, is your company big enough? Is your project big enough? If you have 8, 10 or 15 teams that are going to work on the same code base, then micro-frontends in general and all module federation might help you. But for smaller companies, smaller projects, I wouldn't bother. The gains that you have are not going to be enough to warrant to warrant the amount of complexity that you have to build. Then, is there a team in your company or in your organization that will own the tooling, will own the maintenance of this entire complexity that you will at some point build? If you do not have a specific owner, then again, you will have individual contributors who are going to code something, add a bunch of complexity, then maybe leave the company, and there will be no one who actually understands or has a vision of how this kind of complex system should look like. Then, is your project long term? Is it ever evolving? Because if your project is some kind of short term, like 1 year project where you code it, give it to a client, and then maybe do some kind of maintenance work 6 months down the line, why would you even go? If the project is not evolving, then why would you even consider this kind of complexity? Just go with monolith if there is nothing wrong with monolithic code bases. And then, is this a requirement of the product that we are working on, that you actually need this constant stream of updates? So, for example, at some cases you don't even need CI/CD. You can get away with doing one deployment every week. There's nothing wrong with it, unless it is requirement for your product. You need those constant stream of updates. You need your teams to be independent. Then you can consider going with module federation. And then the most important takeaway from is, if you were to remember one thing, is that remember that with great power comes great responsibility. And the advice is that whenever you see something new, something which is super hyped, or someone sells you this one simple way of doing micro-frontends, then you should probably take a step back, build a proof of concept, introduce it to a smaller project, like a private project, for example. First, try to break things. This is very important, and only then you will be able to make a responsible decision if this is for you at all. And that's not to say that a module federation is bad. It is great. Other teams that have actually done this all right are very happy with the solution. So we have, for example, been able to reduce the length of our pipelines from an hour plus, and they were super unstable. And the teams that have actually opted to extract their functionality into micro-frontends are now happy with 10-minute long pipelines and pretty stable deployments. Okay, that's it. Thank you very much.
Can I get some juice into the mic? Thanks. Okay, I think we can all agree it was an awesome presentation. That was the first time that it has ever been done. So yeah, give it up for Johnny. Hopefully more to come. We'll see. We do have Slido, so if you want to ask some questions, go for it. This will be the same Slido link for all the presentations. But also I'm looking for questions from here, from the room. So raise your hand up if you have a question for Johnny. And don't be shy. We want some questions. There is a question. I'll come.
Module federation and the micro frontends in the new projects and new features within the app, or did you actually do it within some existing legacy ones?
Okay, so then we've actually started with a very big monolithic code base, which was like, you could consider it a legacy, and we have done actually the hard part. So we have started extracting already made functionality from this monolith. We started with some modules that didn't have too many dependencies on the actual monolith, so it was easier to build those or to extract those. But we are slowly moving on to actually extracting, the very core, or at least at some point we'll have to extract the very core. But there is a lot of groundwork that we have to do. So for the libraries that I have mentioned, we have a lot of extracting stuff into libraries from the monolith first, before we can move on to extracting some more of the core, core pages, like your homepage, for example, or the listing page in our app.
Do we have already some questions in Slido? Not yet? All right. Anybody else? One more. Let's do one more.
You mentioned you don't want to create too many shared packages.
Mm-hmm.
So I assume there is a code duplication. How significant is that, and how does it affect the bundle size? Because in e-commerce, speed is money, right?
Sure. Code duplication, it depends on what you do. So, for example, those libraries, again, I am mentioning them constantly because they actually let us do as little code duplication as possible, because whenever you have for example, set of utility components that you want to be reused by other micro frontends, you can extract them into a library and then they can be reused. In module federation, how stuff works is that you can define some dependencies. They can be third-party or your first-party dependencies, the packages or libraries, as shared. So the runtime of module federation is going to actually resolve and make sure that you only wrote one copy of all those dependencies. At some point, some code duplication is not an issue. For example, if we have like some really stupid utility function which doesn't warrant extracting it to a library itself, then redefine it in your own micro frontend. That's okay. Like, all this stuff is lazy loaded either way. So if you make changes, for example, in a micro frontend that deals with user accounts, so if you make this bundle bigger by 20 kilobytes, it doesn't matter in the grand scheme of things. And we are not increasing the bundle size of the rest of the pages, the critical, for example, flow that is critical for performance.
Right, cool. Let's try and do it one more, and then we should be done according to the timing. Are there major differences in implementing module federation with server runtime like
Yeah, so server-side rendering is harder with module federation. So when we first started working with module federation, it was 2 or 3 years ago, then it was virtually impossible to do server-side rendering. Right now there are already tools which the community has built that allow us to do server-side rendering, and actually we'll be experimenting next year with server-side rendering in one of our jobs type of micro frontends. And also for Next.js, I believe that there are already extensions to the framework where module federation should work out of the box with Next.js, if this is what you are after.
All right, we will get back to everybody about the slides. We will also try to park all the questions. Just give a good look at Johnny. He's a guy in the Adidas sweatshirt. Yeah, you can find him later. And then one last round of applause, please, for him.
Thank you for that.
All right, and now let's welcome to the stage Aleksandra Sikora. Give it up for Aleksandra. So a quick round of introduction while Aleksandra is setting up. Aleksandra is an open source developer at the Guild based in Wrocław, Poland. Previously a tech lead for the Hasura console. Deeply passionate about open source, TypeScript, and dedicated to staying up to date with the JavaScript ecosystem. So a hand up, who's currently not using TypeScript? All right, so we have a good crowd for Aleksandra. I think let's increase our knowledge of TypeScript, and I'm handing it over to you.
Thank you for having me here. Okay, so my talk today will be about REST APIs and how to make them type safe. But I will also talk about APIs in general because REST may not be the most popular choice nowadays. So I was already introduced. Thank you for that. Few other things. You can find me on Twitter and DM me. I'm Aleksandra Says. Bureaus on GitHub. You can also check out my personal website, aleksandra.codes. So, yes, this talk will be about APIs. Before I dive into feTS, I wanted to cover, why do we need APIs? Why do we bother? So, firstly, I'm missing a slide, but it's fine. Okay, so why are we talking about it? Well, we're talking about it because when we are working on a front-end application, there's probably somewhere we have a data. And we can't access database or any kind of data store directly because that would expose all the database credentials because they would plant in the browser. So we usually have a server that is responsible for handling all the connections to the database. But that means that we have two separate entities, the client and the server part, and we need some kind of bridge that allows them to talk to each other. So an API is that bridge. But the problem is that while we can have a perfectly crafted front end and back end, and how do we maintain, for example, type safety? We have a bunch of problems. Firstly, there's a lot of boilerplate. We also deal with repetitive error handling in this API layer. And very often, if we are dealing with REST APIs, this is how our project looks like. So what do we do about it? Well, we'll see later how to deal with that with feTS. But before I talk about feTS, I want to take you to through history and through all different API solutions to see what are the differences and to see when and why we would want to still use REST. So we're going to start in the early 80s when this all started. So it started with RPC, Remote Procedure Call. So what it is, imagine you have a function in JavaScript, you have this function welcome, and I should have changed the whole wording, but it's fine. Normally if it's on the same process, then you would just call this function. But now, what if this welcome function is on a different computer? Well, you need to start some kind of server, and in the context of HTTP, you would use a fetch, and you would call the server, and basically the welcome will be in the URL. So this is more or less the idea behind RPC. It's like calling remote procedures as if they were local. But there were a bunch of problems. It makes the server, whatever you have, all the procedures that you have on the server, they are not easily consumed by multiple clients. And they are mostly meant to be within the same used within the same project, and it's not very easy to make public APIs out of that. So the biggest problem turned out to be that it's non-agnostic. So then people were like, okay, so how can we have something fully agnostic? So the next thing was Corba in early 90s. And then it heavily relies on object-oriented programming. So there's this object request broker, and it's responsible for communication with the client and the server. And basically, the client is something that requests objects, and the server has all those objects that are there to be accessed. And those one huge development that happened around this time. Well, in order to be fully agnostic, like so that it's possible to use it like between different languages, they introduced something like interface definition language, where you like declare the basically what's the structure of whatever is there on the server. Like one of the most popular IDLs that you might have heard of is currently protobuf. But it was quite difficult. Like this whole idea of being fully agnostic, like language and platform agnostic, added a lot of complexity, and well, that's one of the reasons no one uses it anymore. So the next thing was supposed to be much simpler. So in the late 90s, there was simple object access protocol, and basically this is how it looked like. This is an XML. You would have a request with the SOAP envelope that identifies a SOAP request. There were a bunch of other like entities like SOAP header, SOAP body, so method, parameters, and so on. And you would basically like the response is very similar. There's also like the SOAP envelope that identifies that this is is a response from a SOAP API. And this one is actually still used these days, especially in places that require more secure systems, in like possibly like airline systems. But the problem was this XML. Like it was quite heavy, so it required like way more bandwidth on the network. So the next thing that people were looking for was something light, and this is to year 2000. The web started changing, like the work on HTTP was progressing, and the same working group that was like constructing HTTP created REST. So REST is a set of constraints, and by default, like this, there was this thing I mentioned with RPC that it wasn't easy to be consumed by multiple clients. So with REST, it's the opposite. It was meant to be consumed by multiple clients, and server basically exposes some resources that it has, and the client can request them or update them. So to compare it to SOAP, well, the difference was in this heaviness. Like in SOAP, you actually had to say a lot to get your data, and the response was actually also quite elaborate. While with REST, you basically just ask, like, give me this resource. And to compare it to RPC, you can think about it as like procedures versus resources. So this is how a similar API would look like in RPC and REST. So in RPC, you are more like asking the server, hey, can you call this procedure for me? While with REST, you're more like, hey, give me this resource, or hey, update this resource. And then we can also talk like how RESTful are really all those REST APIs that are out there. A lot of them are just, they rely on the context of RPC, that is a JSON RPC. But still, like no matter if it's like fully RESTful or like somewhat REST, there are some, or there were some problems that people figured that, well, it's time for something new. And a lot of them boil down to REST not being flexible enough. And, well, the next thing that happened in the API world was supposed to be way more flexible. So around 2012, we have GraphQL. So in GraphQL, here's a comparison of a similar request. So let's say you have your server, and then you have like users. It's probably like a to-do app. So you have users, and they have tasks, and all those tasks have different tags. So in a REST API, you would need to make multiple requests to retrieve all the data. While in GraphQL, there's only one endpoint, it's usually GraphQL, and you send a post request with a JSON body, and inside of this JSON body, you have a GraphQL query or mutation or subscription. So in other words, it's the client that controls the data. So you have a schema that defines what is available on the backend and what are the relationships between different objects and what are the operations that are possible. And then the client decides what it wants to do and what data it wants to get. So some of the problems that were there in SOAP were also a case with GraphQL. For example, this it's also a post request if you are using HTTP, which means there's no caching on the HTTP level unless you are using like a dedicated CDN. But you can't leverage like the one that is there out of the box. And another thing is that GraphQL very often requires extra work to like write the GraphQL backend. It's usually worth it, but it's still it's still a lot of boilerplate unless you use tools like Hasura or PostgreSQL that generate GraphQL API from a database. And another thing that you have to do in order to have type safety, you need to like generate types. So use tools like GraphQL code generator, for example. Which is, by the way, I didn't mention what the guild is. The company that I'm working on, like one of the tools we are maintaining is GraphQL code generator. So that's where like the things with GraphQL. And naturally, the next thing was supposed to eliminate this problem of, this extra work for type safety. So around 2020, people started revisiting the original promise of RPC, meaning the promise of being able to call remote procedures as if they were local. And why it happened? It happened because something else happened, because we had Prisma. And suddenly dealing with databases became much, much easier, and we had this great API, fully type safe. So it was a time for APIs, this API layer, to catch up on that. If you are not familiar with Prisma, it's an ORM, and you basically, you have types from your database, and you can fully type safe perform operations on your database in your JavaScript, TypeScript project. And also around this time, like we had way more full stack frameworks. Like we had Next.js becoming like more and more popular. We had tools like Blitz.js or Redwood.js, and that was like in 2020. Like now we also have like Astro, Quick, Solid, and more. So suddenly the client and the server were already like so close to each other, like they were in the same repository, it was the same project. So why do we have to like lose this type safety? And why do we have to like put this wall between them? So it was a natural thing to kind of like minimize this distance between client and server. And it turned out that RPC is a great fit to do so. So some of the things I already mentioned before. So yes, I forgot about tRPC, like of course. So we have tRPC, query and mutation procedures, Blitz RPC, they call it resolvers. There's Quick, there's also something like pRPC, React Server Components, Remix Loader Pattern, and now there are even more. So then some people started complaining like, so isn't it actually PHP? Well, I don't think it is. I think it's another iteration of things that were already there. And the thing is that even if it might like resemble some other, like for example PHP or the RPC from back in the day, it's still like so many things around evolved, like Prisma, TypeScript becoming popular, that like the API layer, even if it leverages some concepts from before, those concepts are aligned to what is there currently. Okay, so now we have 2023. And what's the problem now? Like, since we get to this perfectly type-safe world of, having tRPC or other like RPC-based solutions. What is missing? Well, the thing that is missing is that tRPC makes a huge assumption, and this assumption is that client and server are and will be tightly coupled. And they also even mentioned that like very directly in the documentation, and that is that can be a benefit, but it can also be a disadvantage. And we may not always want that because we are still very often dealing with third-party legacy APIs, or we have backend written in a completely different language. Like as soon as we have bigger company, bigger project, this promise of having this like client and server tightly coupled is not enough anymore. So yes, the problem again that we saw is that it's non-agnostic, even though it solved other problems. So once again, same as in early 90s, we would like something agnostic. But this time, like the bar is way, way higher. We don't want to go back to Corba. We want something that is also type safe out of the box. Like we don't want to like take a step back and go to this non-type safe world. So what else can we have? Well, now we're going to have REST again. So there are a few projects. I'm going to talk about one of them, about feTS. Another one is Bridge, which is a TypeScript Node.js framework that makes it easy to create REST APIs. There's Stainless that they provide SDKs from REST APIs. There's also Elysia that is meant mostly for BAN, but is also on the concept of REST APIs. And yes, now I'm going to talk about feTS. So feTS stands for Fetch and TypeScript. I got a lot of feedback that it's not the best name. And I'm still thinking about a better one. So if you have any ideas, then let me know. I would really, really appreciate it. So now I'm going to show you the code. I will make it bigger. And I will also drink some water before I do. Okay, so now that we covered like all the different API solutions and why we were kind of like going from one to another, like what problems they were solving, like the thing that so feTS is something that we created internally in the guild. So like something that motivated us was dealing with those third-party REST APIs and not being able to have type safety. And we were like wondering what to do with that. We didn't want to like generate any SDKs because we didn't want to add to a bundle size. And like one thing that we thought was like there's always an open API specification. So if you are not familiar, an open API specification describes your REST API. So basically, I think I have it running here. No, it's not running here, but if I open Swagger somewhere, you might have heard the name Swagger. It's what it used to be called, but then it became an open API when it was bought by the Open API or acquired by the Open API Foundation. And now we have Open API 3. Open API 3, basically. So so that describes your REST API. You might have seen this view somewhere, like you have all the endpoints that are there available, like what are the different, like, for example, values. That's probably not big enough. So make it bigger. There's also a schema that you can expect from this API. So this open API spec is something that feTS heavily relies on. So in order to use it, this is like the first requirement. You need to have this documentation of your REST API. So in here, I have Spotify's REST API documentation. And the next thing I'm doing is I'm creating a new feTS client. So we'll go through like the feTS setup, like what is required to be able to have a fully type-safe access to third-party REST API. So I'm importing this create client function from feTS and normalize OAS from feTS, which this is a generic type. It takes the type of this open API object and it only changes a few things so that it's easier to understand to this for this create client function. Yes, I'm using this create client. I'm providing the endpoint that we want to hit. And now if I hover this, then this is like this OAS client, and it has all the information that are there in this Spotify's API. So now how to use it. So I have this quite simple application. I was scared for a second that this is my alarm, but my phone is here. That's good. Okay, so I will show you the application first. So basically, there's just a question like, hey, what's your mood today? And the goal is that you can select and you have 3 songs from Spotify. And how does it work? So I have this fetch recommendations function. And here is this feTS client that I imported from my from the file that I was showing before. And now feTS knows that there is, if I comment this out, I will show you that feTS knows that there's only a get method available on this endpoint. And also if I go back and if I, let's say, change this limit to a string, it should be an error. Yes. Took a moment. Yeah. So it knows like what are the like what is the schema of that, because it was it infers the type from this open API object. Like the important bit here was that I have this as const at the end of this object, which tells TypeScript to infer precisely what is the type of it. We're not interested in just like any object. We want to know exactly what are the fields there. Okay, so going back to this app, basically it knows everything that I'm able to pass in this query, and it also knows that this Spotify API requires headers. So now this returns the promise. We also know like what kind, like that doesn't tell us that much, but now we like it can be an error, or it can be it can be a success. So we want to see if there was like if there was an error, if it's not okay. Then I'm also checking the status, because if it's unauthorized, then I'm trying to refetch the Spotify's token to try and fetch my recommendations again. And also like all the statuses that are there that like the API returns should be documented in the Open API spec. And then if it's okay, then I call the JSON function of this response. And now I have exactly what's there. I see that there's this recommendations object. Inside we have tracks, and I also know what is the what is inside. So wherever I'm using it, yeah, I guess here I know what the track is. So now I guess I have a little bit more time, so I think we can try to add something else. So let's do const fetch something, because I don't know what we're going to use yet. If you have any suggestions, then let me know. So let's do this Yeah, I probably want this to here as well. So now const response, yes. And now I'm going to show you how it knows all the endpoints that are there. So we could basically see everything that is there available in Spotify, as long as I have permissions with my Spotify token. But I don't know, maybe we can do new releases. So now it also knows that there's only get. If there was like another method available, like post, put, update, patch, then it would also suggest that. And now what we have here, yes, we have headers, same as before, but it's not enough. Now we have an error that, let me remove this. I do have headers. Yeah, my computer is just very slow. It will catch up in a second. So it also requires query, and in this query, we're going to see what we have here. Okay, we have just limit and offset, so I think it's pretty reasonable to set limit to, let's do 5. And I'm going to copy this signature quickly. We don't need mood. And now we're going to see basically the same thing. I could actually rename this function right now to fetch new releases. Okay, and now, yes, it's very slow. Okay, now we're going to await it, and I'm just going to return the new releases, and also going to restart TypeScript so that it's faster. And yes, okay, I see that there are albums and so on, so we can for it to be faster, I think I can just copy this so that we have basically almost the same view, but I also want to call it. So here in this demo, I'm using React query because basically you can use feTS with anything you want. I'm quite used to React query, so I'm using this. Okay, so we have this new releases, and yes, new releases. And what do we have here? So, come on, TypeScript. Well, why is it any? Okay. Oh, because this fetch new releases returns any. Okay, that makes sense. So, because basically we're calling it also there. So here I wanted to show you something else. Like in the Open API spec, you have all those different schemas as well. So sometimes you just might want to like extract the type of something in particular. So there is something like a bunch of utility types. I showed you before this normalize OAS, but there's also something like the model type. So you can get type of the user schema, for example. And there's also something for the response body. So this is probably something that we would like to use here in order to have the type, like, you know, to know what's the new releases thing. So if I will do type new places, and I will use this thing. Would be easier if my TypeScript was faster. And yes, this is the endpoint, and I want the output of the status code to 100, and I want to, where's feTS? Oh, that's not here. I want to import this and this from, not from this, from feTS. But I also want to import my OpenAPI spec from, okay. Did I make a typo? No. Come on. Yes, this is fine. I promise it's usually faster than this. But you get the idea. Now, if my computer was faster and my TypeScript was faster, I would have the type exactly the same thing that I see here. And for a moment, I will actually comment this out so that now this part should know that there are albums. Yes, now it knows. What else is there? There are items. This can be undefined. This can be undefined as well. So now we have item, and we have item ID. This should be the same. There is ID. So I go to the app. I don't have that much time left. Oh yeah, thank you. That was very helpful. Come on, where are my items? Oh, there's item. Maybe my token expired. Oh yeah, it's unauthorized, but if I do this, and we'll try to run it again. One. Okay. It's still unauthorized. So I'll just copy this and paste it here. This is not secret token, so it's fine. You see it. Okay. Okay, come on. Where are the new releases? Oh, right. Okay, we have new releases. No, Spotify is not behaving great. But I suppose this is the same code. And we had tracks. So I suppose that maybe if I change this to album. Yes. Okay, perfect. It worked. So this is how we work with feTS. And now I'm going back to my slides. I don't have that much time left. Just hide it, make it bigger. Okay. So in summary, there's type safety out of the box. There's no runtime overhead. This is just types, so they will be all gone in your bundle. And you have all the IDE features, usually much faster. And go to definition and so on. If you scan this QR code, it will take you to the documentation. It's not only feTS client, there's also a server part. You can create REST APIs with feTS. I only covered the client part and how to work with external APIs. So to summarize, it may look like we are going in circles, but I don't think that we are going in circles. I think that we are removing all the levels of complexity and we are getting to newer and better solutions, even if they leverage some old concepts. And this is actually another one of my favorite comparisons. Well, we may not have like exactly the same baggy pants as we did, but you know, there will be like an improved version, same as with APIs. And another thing to remember is that, you know, the fact that feTS exist, or the fact that, you know, tRPC was very popular, doesn't mean that you have to like, you know, just ditch everything else and just dive into tRPC and like say that REST is dead or like GraphQL is gone and like, you know, you never used that before. It still depends on the project you are working on. And this is another, like, one of the interesting examples. Dylan, this is someone I used to work with, asked on Twitter, like which framework, was like that there was a poll, like, what framework are you choosing? And like Dax rightly mentioned that, you know, like there were so many votes and so many comments and people were so opinionated and no one even asked Dylan, like, what is he building? So that's very important. So like, remember to, like, you know, it's one thing to know about the new solutions and it's one thing to be familiar with them, to play with them, but it's your project and your team that will have to use them. So adapt them to whatever your project needs at the moment. Thank you very much. If you scan this, there will be slides. Thank you.
Fun to one too. Let's see if we have some questions on Slido already. But in the meantime, let's do one from Slido, one from the room. So anybody here has a question to Aleksandra? Raise your hand. If not, we'll be looking at Slido. Not yet. Don't be shy. It was a lot of live coding. Definitely somebody has a question. All right, we have one.
Does it work? Okay, it works. That wasn't the question. So, when actually does the schema is sort of being downloaded? So when you see it in your IDE, right, it gives you great types, everything. But how exactly library knows that, hey, this is your schema for this particular endpoint? When does it happen? Actually, do you need to run something? Does it happen on the fly? Where's the magic?
Yeah, so the magic is you have to have it, basically. So when you are working, for example, with Spotify, I know that Spotify has a public open API spec. I can go to their documentation. I can just basically grab it. And if I was working on a project that is using Spotify API, then I would have a CI action that regularly updates the open API spec. And that's the automation that usually has to happen with feTS. And so that's one thing. Another thing is, when you are working with it, like inside the same company, then your backend team is meant to provide you with the open API spec if they are using REST. Or alternatively, if you are writing the REST API yourself and if you are using feTS, like the server part of it, then it just generates it out of the box. You don't have to provide a separate JSON object. You can just, like there was this code like create client, and then I was providing type of this open API spec. So if you were using feTS server, then you would just provide the type of the server function. And the API of that is very similar to tRPC. If someone is familiar with tRPC, then it's more or less the same.
Cool, thanks a lot. I don't think there's anything popping up yet on Slido, so give it up for Aleksandra for an awesome presentation. Lots of live coding. So the order of events, we will have part number 2 with Daniel's presentation, and then we will go into Q&A, so you'll have more chances to ask questions to all the people that have been on the stage today. But for now, we're doing a 15-minute break, but this is really 15 minutes, so I'm going to put up a timer here. Let's be concise with time. For everybody here in the office, there are some snacks and coffee, tea, drinks available for you. It's not available for everybody on Zoom, so you guys have to make a run to the office or have to figure out what you have in your kitchens, but we see each other in 15 minutes. Okay, cool. So on stage, we have Daniel Afonso. So big round of applause for Daniel. He He came to the winter Poznan to go from all the way from Portugal, so definitely a big change, but we really appreciate you here, Daniel, and looking forward to your presentation. So, a quick intro. Daniel is an author, instructor, and developer advocate at OLX. Daniel has a full-stack background, having worked with different languages and frameworks on various projects, from Internet of Things to fraud detection. So, let's go. One last round of applause before the presentation, and let's kick it on.
Okay, microphone check. Let's see. I'm not hearing myself. Okay, I'm hearing myself now. Okay, everyone, thank you so much for joining. Sorry for bringing you back from the networking that we're having, but we're going to go back in a bit, so hopefully you won't fall asleep right now and you're going to be a bit more energized afterwards. Before we start this talk, and I just want to put a disclaimer, you are the ones who's going to make the talk that we're going to listen. But because of that, we need you to vote. I need you to go to this link and choose 2 topics. And from these 2 topics, we'll define the talk that we're going to see today. So it's really important that some of you at least participate, because if we don't have votes, we're going to have to, I don't know, that this never happened. So hopefully it won't happen today as well. This QR code will keep showing on the next couple of slides. And I'll just do a quick introduction on what is going to happen here today. So, going to conferences, going to events, going to meetups, can be a bit overwhelming. There are technical concepts, there are words that you don't often know the meaning. And the reason for that, for me first, it's because of the language barrier. Being Portuguese, sometimes all the words, you see these words in English that you hear like, okay, but this for me means one thing, but in the technical scope it means something completely different. And the second thing is because of mental models. The reason is because I don't have or didn't have the right mental models formed. For those of you who are not aware of what mental models are, well, basically when you hear a word, mental models are the steps in your mind that you associate with those words. So for instance, if I say sleeping, you know all the concepts and all the parts associated with sleeping in your mind, because you have the 4 mental models of how this thing happens. And this was one of the things that I was missing with these technical topics. Now, parking that a bit, I want to tell you something about myself. I'm a huge comic book nerd. I have more comic books than I can read, partially because I don't have time right now. But why am I telling you this? Well, because I love tech. I love comic books. So I thought, what if I picked a boat and I built a nerdy guide to the web trending concepts? Now, this part, before I'll explain a bit more what's going to happen, let me just reintroduce myself real quickly. I'm Daniel Afonso. In case you don't recognize me, I'm this person here. The other one is my pair programming buddy. I'm working as a developer advocate here at OLX. I'm an agile instructor, author ambassador, and you can find me on X, Twitter, whatever you want to call it nowadays, and pretty much any social network at the handle Daniel JC Afonso. Something about me recently, I released a book called State Management with React Query. It was published this May, June, something like that, which is pretty much my experience of using this amazing library that I really love called React Query. It is not what we're going to be talking today, but just putting it out there. And last week I released this course on Aglet called An Introduction to React Testing Library. So if you're interested in learning more about testing library as well and on React part, you can also check it out. Okay, a disclaimer real quickly. This talk that we're going to see now is going to include some characters that are owned by either DC Comics or by Marvel. It's just important to put this out because, well, we don't want any copyright claims. So, before continuing, I may help for sharing some love, and I want to thank 2 people that helped me shape this talk. One of them is Attila Facina, and the other one is Mateusz Albuquerque. You can give them a follow on social media, but basically they are the ones who reviewed my mental models and helped me shape the talk that I'm going to be presenting to all of you. So I just wanted to put this out there and share some love with them. So a huge Keanu thank you meme. Okay, now for the fun part. How will this talk work? So far, you have been voting. From the things that you have been voting, we're going to pick 2 topics. And from those 2 topics, something is going to happen, because then you are going to decide again. And this animation is very slow. Let's see how it goes with the other ones. You will decide again, because imagine that you pick topic A. For topic A, you're going to have 2 characters, one from Marvel and the other one from DC. And each one of these characters has a different story, a comic book story, but each comic book story will help you build the mental models of the concept underneath. So for instance, as if you picked hydration, we're going to see hydration from character A or character B. It's going to be different stories. Now, there's this animation. How are you going to decide? When we get to these characters, I'm going to ask you to clap. I know it's cheesy, but just to bring some energy in a bit. So when we get to the characters, I'm going to ask you to clap. And then, like I said, we're going to get a comic book story. And then afterwards, we're going to get the technical explanation on what actually we saw on the story. So if you open and you voted on these 4 topics. So now, let's see if this worked. Let's see, what did you vote on? Let's see. Okay, this is getting very slow. So let's see if we can figure this out. Cool. Okay, interesting. So first one is edge computing, and then we're going for fine-grained reactivity. So these are the 2 topics that we're going to see. And actually, fun fact, this is the first time I'm going to do edge computing in the front of the audience, because I've done this talk a couple of times already, and so far nobody picked edge computing. So I'm excited, because that's going to be the first time today. Okay, so let's get back to the slides, and I need to click here. Okay, edge computing. For edge computing, we have 2 characters. We're going to be introduced to either Nick Fury and S.H.I.E.L.D. or Amanda and Argus. So this is the part where I'm going to ask you to clap. So clap for Nick Fury. Okay. Clap for Amanda Ward. Okay. I know where we're going, so let's go with Nick Fury and S.H.I.E.L.D. So during this part of the story, this is going to be like reading a comic book story, and I'm going to assume the narrator role. So if this is weird for you, I think it's weird for me as well, but hopefully by the end of it, we'll have the mental model of edge computing. So let's start this thing. New agents, welcome to S.H.I.E.L.D. Don't forget your goal, defend the Earth. So it's time for a story. A story because when we first started this agency, when we started S.H.I.E.L.D., our base was located in New York City. Now, as we started growing and working on our goal, which is protecting the world, we soon found one issue. And what's the issue, you might ask? The first one is the animations are slow. But the issue is we could not get to every place as fast as we wanted to. Incidents happen around the world. But you see, there are times that, well, we need to travel. If we want to go to the parts of the world, we need to cross, we need to fly. There's no teleportation. Well, it exists, but they didn't have the technology yet. And not to mention, well, doing this thing is expensive. We have to mobilize our resources. We need to take them out from our city to go to this new place. Now, we did some studies, and we soon found a pattern around the world. Wakanda as Black Panther, Latveria as Dr. Doom, Krakoa as Professor X, and Attilan as Black Bolt. And we started running some studies around these heroes and their time to response, because we figured out something really fun, which is all of these heroes could respond in incidents faster than us. Now, you might be thinking, we were trying to think, okay, why? Why did they have a faster time to response than us? Well, some of you might already got to the reason, but the reason is they are closer than us. They were closer to the places where these incidents were happening. So when an incident showed up, they were there. They could respond faster. They didn't have to travel all the same amount that we had. Now, how did we fix this issue? Because we fixed it. Now everything is working pretty well. And we fixed this issue by introducing bases on those same places as well. Now, after a while, we ran the same scenario. And the same scenario is that right now we have more bases spread around the world, and the fun thing, our incident time to respond, now it's less. So we are responding faster than the main local heroes. So we are getting there faster, we are responding faster, and the incidents, well, it doesn't happen as often because completely different story. In the case we need help, that's one of the things that you might be thinking. In the case that we need help, it's cheaper because the agents on site already did some research and they can target specific needs, and we only send the people that we need to. So, with that said, agents, I want to assign you to the carbon base, and good luck and make us proud. Okay, so for those of you who are familiar with the concept of edge computing, you might have already picked up on some nuances, but let's just recap what the heck Nick Fury was showing us with edge computing. So edge computing is there to solve one problem. which is, well, first of all, cloud computing can be a bit expensive. It can induce latency, and sometimes when there are times that we need split-second decisions, going to the cloud can impact that. So if we run a scenario, if we're there in Portugal, if we are on the other side of the world and our server or cloud is somewhere there in the middle, usually doing this can have some latency because we have to do all the round trip from there and back. Well, with edge computing, we introduced this concept of edge nodes or the edge, which are servers or computers or whatever that are closer to the location. So if, for instance, here, oh wait, let me just get the clicker because people online cannot see it. If here we need the data, instead of going all the way to the cloud, we go to this edge node that is closer. This means that we have a faster response time, and it also means that it's probably going to be cheaper because there's not all the type of processing. If we still need to go to the cloud, the edge node can do this and save us some extra costs. So there's all benefits here. Now, looking at the story, let me just get the clicker out of there. Looking at the story, now we're going to see all the parts and what we're trying to tell in each point. So the first part, what we're trying to say when we're showing this part of the story is that cloud computing can be expensive. And it can also induce latency. That was the issue that Shield was having. They couldn't get to the incident as fast as they want. And when they did, well, it's a bit expensive to send the resources. Another thing, getting data from the edge is faster than doing it from the cloud. That's the study that we got here, because we figured out that if there are local users, which are our users, they responded faster. So we figured out, wow, maybe if you're closer, you're going to respond faster. Cool. So this is kind of the gist of what we're trying to say here. This one, it's a bit weird. I can confess, sometimes transferring mental models to stories, it's hard. But what I was trying to share here is that the edge device can be anything. It can be a user computer, can be an IoT device, can be an edge server. In these cases are the bases that Shield threw out around the world. And finally, because the edge is closer to the device, it will be faster to get the data from there. And it's also going to be cheaper because, like I said, you can do the processing on site. And in this case, if you had also agents on site going there, it was easier. So just to recap what we saw in the last couple of minutes, let's recap the entire mental model of edge computing. There's a problem. Cloud computing can be expensive and induce latency. When you need to do some computing, well, instead of going to the cloud, we can go to the edge. What's the edge? Well, the edge can be a user computer, can be an IoT device, can be an edge server. It can be plenty of things. Because the edge is geographically closer, and this is the main point here, it's geographically closer, it will be faster and often cheaper. So this was edge computing in a nutshell. So we have 15 minutes. Let's go to the next topic, which was fine-grained reactivity. Let me get back here. A lot of clicking. So fine-grained reactivity. Now, you know the drill. For fine-grained reactivity, we're going to have two different characters. For Marvel, we have Watu, the Watcher, and the Watchers. And for DC, we have Batman when he got access to the Mobius chair after the Darkseid War. So, who wants to see Marvel, Watu, and the Watchers? Well, just who wants to see Batman? Okay. So let's click on Batman. The linking work. So, after sitting in the Mobius chair after the events of the Darkseid War, Batman was the owner of the Mobius chair. The Mobius chair, for those of you who are not aware, is a device that, well, allows you to control time and dimensions and travel through them. After the Darkseid War, like I said, Batman was its new owner. And because of this, Batman could see it all. It could see all that passed, all that is passing, and all that will pass at the same time. Now, how does he do that? Because of these things called time points and time derivations. For those of you who hopefully you're seeing this, time points are the ones in the middle, the blue ones, and time derivations are the gray ones. Now, what are time points and time derivations, you might be thinking? Well, time for the animation to pass. Like the name might incline, time points are points in time where specific events happen. Some stuff happened in the timeline and they are stored in time points. Now, time derivations on the other side around are, well, let's imagine that you apply some changes to a time point and you want to see what would happen if you change something. So you would get a derivation of time, therefore a time derivation. Now, usually you didn't make a lot of time derivations because it's a bit tricky to do this research, even with something as advanced as the Mobius chair. Now, Batman knew something. Batman knew that he wouldn't change the past. The past is in the past. It was what turned him in what he is right now. Now, the present and the future, well, that's a completely different story. That he can change at will, and he will. Because every time a time point changed, Batman would get notified. He would know, because the Mobius chair would tell him. And because of that, well, it means he has all the power in the world to do whatever he wants. So this means that Batman will make sure that nothing bad will ever happen to anyone again, like it happened to his parents, like it happened to all the other persons and people on the world. So let's picture a scenario, looking at time points. Let's imagine that the rogues are attacking Central City. What happens? Well, in this case, Batman sends the Flash. The Flash goes ahead, he fixes the issue, and, well, because Batman interfered, a time point was changed. Now, there was a time derivation associated to this, so that time derivation is recalculated as well. Imagine for another scenario that Mr. Freeze is robbing Ace Chemicals. Well, in this case, Batman will send in Robin and Red Hood, and they will take care of the issue. And once again, a time point changes, and the specific time derivation. Now let's picture for another scenario. If in the future, looking at the future, Batman knows that Metallo will attack the Daily Planet somewhere along the future, but Batman has planned for it. So what Batman will do? Send Superman. And Superman takes care of the issue, causing, you guessed it, another time point change and the respective time derivation. Now, soon there was an issue here because Batman became obsessed. He became obsessed with solving this. And he became obsessed to a point where he was even stopping ordinary crime before it happened. It got to a point that the GCPD, the Gotham City Police, couldn't hold more criminals or soon to be criminals because there were so many people getting locked up that there was no capacity to handle all those things. Now, all of this took a toll on Bruce. You see, Bruce is human. The Mobius chair was made for gods. Mobius, for those of you without aware, is an anti-monitor, is one of the ancient gods in the universe in DC Comics. So, if you want to know more about what happened, you can actually read the comic book where the continuation of the story exists, because this is based on what happens in the Darkseid War. So if you want to know more what happened next, you can check issue 32 of the Justice League from the run on 2015. So what we saw here were all the concepts and all the things that you need to know about this thing called fine-grained reactivity. So before we dive in what fine-grained reactivity is, we need to dive in on what reactivity is. Now, reactivity is defined as a programming pattern that will let you set a behavior that automatically reacts to some data changes. Now, what does it mean to have a fine-grained reactivity? Well, it's pretty straightforward. Because when you have a fine-grained reactivity system, it means that you're applying a reactivity pattern built on top of certain primitives, like signals and effects, and memos as well. So if you're familiar with top servers, with drives and all those things, this is kind of the system on when you're building a fine reactivity by itself. The fun thing about fine-grained reactivity is that these primitives allows the framework to know exactly where the update needs to happen. So there's no need for re-rendering. One great example where fine-grained reactivity is applied nowadays is this framework called Solid.js. Some more frameworks are applying this nowadays, but in Solid, components only render once. And because of fine-grained reactivity and because of signals and effects, Solid knows exactly when updates are happening and where to update on the UI. So there's no need for re-rendering out all the stuff like you have in React. And that's pretty much what I just said. So looking at some Solid code, if you're familiar with React, this is all JSX, so it should be pretty much the same thing. But it's signals, starting with signals first. Signals are what are considered to be event emitters. They return a getter and they return a setter. Let me just get the pointer here. So they have a getter here and they have a setter. And by itself it's interesting because this sounds like just a state mechanism to hold some data. But it's what happens next that makes this interesting, because They have this thing called effects. And effects are functions that will subscribe to signals. And every time a signal changes, effects run. So in this case, we can see here there are two effects. There's one explicit one and one implicit. So the explicit one, we're creating an effect by calling create effect, and we're passing our count signal here. So when this component renders once, but if for some reason the count changes, what's going to happen is that this effect is going to be notified because the signal is going to tell the effect, hey look, and this data has changed. So you need to run, and this effect is going to run, and now you have a console log with the count. Now there's also this thing of an implicit effect here because we also have our count with the count signal here. This is an implicit effect because every time the count changes, Solid is going to know that it needs to run an effect to update only this specific part of the UI, only this one. There's no re-renders. Signals tell it that it needs to happen. Finally, memos. Memos are another primitive that allow you to cache derived values. What does it mean? So let's imagine for some scenario that we have this double num function here, which could be derived signal. Basically what we are doing is we are duplicating the value that's in our counter. And let's imagine that we were calling it a bunch of times in our render part. Now, this function is not that expensive, but imagine that there was a lot of stuff there, that this was an expensive function. Every time you called it, this thing would be recalculated. So for the X amount of times that you have the double num count there, this thing would be recalculated. By wrapping this derived signal with create memo, basically you're telling your code that run this once, cache the result, and only when when our count changes, only then you're going to recalculate it and cache the value again. And this means that, well, if you have an expensive function, some expensive code there, it only runs once until your count changes again. So this was fine running activity, and now let's try to figure out how this fits in with what we just saw. Well, you see, time points are signals. They contained a point in time, which was a value. Time derivations on the other side, as you guessed it, are derivations of time points. So in this case, time points were signals, time derivations were memos. Here we had an effect. This effect was running every time the signal it was subscribing updated, because Batman was subscribing to time points. Every time a time point changed, there was like a console log effect, for example, that was telling Batman, oh, something is happening on this time point. Now, after this, Batman decided to intervene. And when he started intervening, what happened? Okay, time point changes, Batman gets notified. There's an effect notification for notificating Batman, and we ran another effect for updating it. Because he updated it, the time point would change. Because the time point would change, the time derivation would also change. And this is kind of what we were seeing there in the last examples. So just to recap what fine grained reactivity is. It's a reactivity pattern that's built on top of this network of primitives, signals, effects, and memos. Let's see. Okay. Signals are event emitters that have getters, that return getters and setters and all the value. There's also effects, which are functions that subscribe to signals. Every time a signal changes, the function that the effect runs. And we have memos, which allow you to cache these derived values. Oh, and I see we have 5 minutes, so I think we can go to another story. Do you want another one, or should I wrap up? Another one. Okay, so let's see what was the other one. Okay, let's continue. Let's go with resumability, because that was the one who was next. Or do you prefer hydration? So, clap for hydration. Okay, clap for resumability. Thanks. So let's see resumability. Let's just pass this part in the front. Okay, resumability. For resumability, we have 2 characters as well. Iron Man for Marvel and Lex Luthor for DC. So you know the drill, clap for Iron Man. Okay, clap for Lex Luthor. Okay, I guess Iron Man takes the win. So, let's start this one. After fighting Kang the Conqueror for the last time, Tony Stark had one issue, which is, well, all his armors were destroyed. Everything was destroyed. You see, there's a lot of armors. Fighting a big bad like Kang the Conqueror takes time and armors. So there were no more armors for Tony, and he had just returned home. Now, let's say he got home. He asked his custom AI, which is Friday in the comic books. And he asked Friday, hey Friday, please remind me tomorrow to build some new Mark suits. I'll take care of it tomorrow. Today I need to rest. I just defeated Kang, whatever. And so he fell asleep. Well, this was a very, very well-deserved rest. Saving the world, his art. But suddenly, an explosion happened. You see, there's another big bad who couldn't let this opportunity slide. This one was the Mandarin. And like I said, Tony Stark was sleeping. After all, this was a vulnerable Tony Stark. So, startled, Tony Stark woke up. And he was like, okay, now I need a suit. I need to make sure I have a suit because how am I going to defend myself? But Tony knew something. Well, Tony had a node process. And this node process basically involved building an armor, downloading his custom AI into the armor. And this process took a bit of time because, well, you have to build the armor, download the AI to the armor, have the AI power up the armor from the inside. Well, this thing takes time. So Tony knew that if he did this, probably wouldn't survive. He wouldn't get an armor built on time. And startled, he asked himself, okay, now I need to think. And Hydra Booms were showing up on the back, as you can start to see. And suddenly Tony remembered, okay, now I need an armor ready to work. So Friday, initiate reasonable protocol. Give me an armor now. Build it now. I need it now. And Friday started building the suit. What happened was, for each interactive part of the armor, what Friday would do, it would include some extra information there that would allow each part of the armor know what is supposed to be doing. And besides this, Friday also did something which is downloaded a very, very small part of itself there. I will show you in a bit why. Well, whilst this was happening, Mandarin was doing his typical bad guy speech. You know, all the monologue, yeah, I'm going to destroy you, I'm going to win, whatever. And during this time, Tony was just stalling for time. Well, it got to a point that Mandarin picked up his 10 wings, pointed his hand at Tony, and fired an explosion blast. And this explosion blast would definitely kill Tony. But what happened is, at this time, Tony jumped, and his armor caught him. So he survived to what would mean probably death for him. So this left the Mandarin to think how. He knew the process that Tony had before. He knew that there is no way for him to have an armor ready. Well, this is the part that I told you about. Because, you see, in the resumable protocol, Friday uploads a very small part of itself into the armor. And what this part does, it set up like this sort of event system that every time there's an order from Tony, it looks at the part of the armor where the information is encoded, downloads the instructions, and runs it. So this means that it was much more faster, and there was no need for all the powering up process that we had before. There is no brute face. When you get an armor, the armor is ready to work. So Tony said, okay, Friday, fire the rockets. And at the same time, he added in the helmet, okay, powering the rockets, Tony. Once the rockets were ready, well, Tony fired them. And what happened next? Well, what happened next is his house and everything inside was destroyed. And this meant that Tony could make an escape and made sure that he could call for backup. Now, what happened next? Well, for that, you're going to have to wait for the next issue, because that's what happened in comic books. Sometimes you're reading, you're excited, and you get to the end, oh, now I need to wait another week. So this was resumability with the help of our friend Tony Stark. These things are funny. So let's figure out how resumability works. So let's just get for the explanation. Resumability is a concept that was made famous more recently by this framework called Quick. And it's there to solve one problem, which is the page is not immediately interactive after doing server-side rendering. And because of that, we have this thing called hydration. The thing is, during hydration, we are redoing the work that we did on server, on the client. So we are doing a bunch of extra steps that we were doing in the server side, now on the client. Ideally, we wouldn't have hydration. So no hydration is better than hydration. So how does resumability fix this? So when you're server-side rendering your code, your HTML is generated and it's serialized some extra information there. The extra information that is serialized there are the steps that part of the code needs to do, and in this case, the instructions on where to get those steps. So once the client gets the page is immediately interactive. There's no need for iteration because everything by essence is already interactive. So you can click on whatever on the page. What's going to happen next is, because of that information being serialized in, the framework is only going to download the needed JavaScript to execute that part of the instruction. There's no need for downloading everything. The page is immediately interactive. There's no need for downloading the entire framework. There's no need for running the entire framework. And there's no need for doing the reconciliation process that we had in things like hydration. So that's also one thing that's important to mention. Once we get the HTML, we also get this 1 kilobyte of JavaScript, which is called the quick loader, which is responsible for setting up a global event handler that is going to listen for these clicks and downloading the JavaScript needed for executing it. So let's recap what we saw in the story. What we're trying to say here is that hydration is slow. The old process that Tony had, we can compare it to hydration. So once the client requests a new page, in this case Tony is the client, he requested a new armor. Once the client requests the page, using the framework, the server will build the HTML page and serializing all the information that it needs to resume its execution in a new environment. Once the client gets the page is immediately interactive. Now, the client also gets this thing called a quick loader, and the quick loader will set the global listener to all the events. So there's no boot phase, which means there's no hydration, there's no reconciliation, there's not anything. So finally, what we saw here is when an event happens, the quick loader, in this case the AI, would intercept it, get the JavaScript needed for executing it. So once we see powering the rockets, we could assume, okay, we're downloading the JavaScript that we need, and we run it. So this was reasonability with the good help of our friend Iron Man, aka Tony Stark. So just recapping on the entire mental model. When we start, the resumability is there to fix one issue, which is the page not being immediately interactive. During hydration, we do the work we did on the server. So when we're doing resumability, what happens is, well, the client requests a page. Using the framework, the server builds a new HTML page and serializes in all the information needed to resuming the context in a new environment. Once the client gets the page is immediately interactive. And if you interact with it, client also gets the quick loader. And if you interact with it, what's going to happen is, because the quick loader set up this global listener, once the event happens, quick loader grabs the event and fetches the JavaScript needed for this execution to happen and runs it. And now I was going to spoil with the next story, but we're not going to see that one here. So, to wrap this thing up, well, what comes next? What's the next topics? What's the next Nerdy Guide 2? Well, for that, I want to give you a challenge. I would love for you to tell me what you would want me to do. Hopefully, we'll have another of these events soon, and hopefully we'll be able to see more of these stories, new ones, because there are many things. I'm working on React Server components right now, for instances. So there are topics, so I would love for you to suggest things to me. So with that, this looks cooler when the thing is not slow. With that, this was a Nerdy Guide to the Web Trending Concepts. Thank you so much for watching.
So thanks a lot, Daniel, for your presentation. Since you've decided to go with 3 things instead of 2, you've eaten out your time for individual Q&A. So here's what we're going to do for everybody that stayed here until that time. We have an extra thing. We will now try and do Q&A with everybody that has been on stage so far. So I'm happy to answer questions about OLX, but we have 3 people who know everything that's hot and new around the front-end world. So if you ask some questions, either on Slido or from the audience, we have an extra prize for you. We will be awarding you with OLX points, so you get 50 points for every question. And we already have some questions on Slido. Awesome. So OLX points, they allow you to basically promote your ads for free on OLX. So I think it's a cool thing to have if you're ever trying to sell something on OLX. So I'm really, really encouraging this.
Can I ask myself a question?
If it's good enough, then definitely. That's a clear way to get more time for your presentation. All right, so we have a first question to Johnny. Will we make a poll about Module Federation usage? I wonder how many of us here used it, tried it, is using it, or never heard of it.
Well, all right then. We can make a poll in a similar fashion as Daniel did. So for those people who did use the module federation in the past, just raise your hands or just clap. Okay, not so many people. Who did use any other micro frontend technology?
Shout what it was.
There was an hand raised there.
Okay, 3 people. Yeah, okay. All right, then. So we have our answer. And then the next question: will those slides get published? Well, will they? I don't know.
I have a suggestion. You can add them on your LinkedIn if you want, and people can connect with you.
Yeah, I could. Why not? So there you
So
go.
follow them on LinkedIn.
So you're definitely publishing the stream on YouTube. Not sure about the presentation. I guess that's a question up to Johnny if he decides to share it with the world or not. Any questions from the room? So I can pass the mic.
Hello, Daniel.
Oh, for me? Okay.
Yeah, Victor from the infrastructure team. Hi, thanks for the group presentation. No. But about the edge computing thing, and maybe partially because I'm old and grumpy, but on a concept level, doesn't the thing kind of resemble maintaining on-premise solutions like servers, etc.? Because, well, if distance and time equals money saved, then why did we go to the cloud in the first place, right?
That's a great question. I think we should get an expert on cloud computing here to answer that question, because that's the main motivation for me to try to build this presentation. Is I had also I was lacking justification on trying to understand what edge computing is in a nutshell. So basically that's what I tried to do here. I said, okay, let's get the basic concept here. Let's try to build a mental model, and let's try to wrap it up on the story. Regarding your question, that's a good one. I don't know if you have any ideas or any thoughts on it, or if you know. Personally, I don't know the answer, to be honest, on that one. That's a tricky thing. I'm not an expert on this, definitely. So yeah, the point of this part was mainly so for when people hear the words edge computing, they think, okay, this is what it means. Because then, especially on the web ecosystem nowadays, I have some thoughts on this, because now with the word edge has been throwing around, when I was doing research for this part, and this is probably the trickiest topic for me to build concepts, because there's so many different resources regarding the edge. Because then there are people referring to CDNs, there are people referring to the servers, there are different ways of interacting with it. So the internet is not what's the word here? It's not easy to research when you're dealing with edge computing. If you have any suggestions, any resources, or anything that you would like to share, I would definitely love to hear it, because to be honest, I don't know how to answer your question. But I had some other... No, but you didn't need to. I think that's also the point here on sharing these things. We don't have all the answers. What we have is what we're trying to share with our talks. I think that's also the point when you're doing public speaking. You're sharing with a goal. In this case, my goal was to, when people hear edge computing, they know at least a bit what the thing might mean in their mind. If they need to do some extra research, then please find people that are far more qualified to do that than me. Yeah, thank you for your question.
All right, we have another one to Jamie. How big is your team that manages the microservices, infrastructures, and tooling?
All right, then. So the team is actually 6 front-end engineers, but we are doing a lot more than just managing the micro front-end infrastructure. So yeah, it would be hard to say how many people are actually full-time people working. I don't know. Hard to answer this question, but yeah, we definitely need more people to work on that and more focus on that.
Yeah, we definitely need more front-end developers. So if any of you is interested, we're welcoming you to talk to us about this. But going further, if you were to start your career, again, that's a great question. What technology would you definitely not learn based on your current experience? So, Aleksandra, I'm going to you first. That's going to be a big challenge, so think through.
If I were to start my career again, possibly I wouldn't learn technology at all. But if I were into technology already, well, there are definitely things that weren't that useful, but wow. I mean, I think in the beginning of my career, like when I was like studying computer science and like even before, I used to learn a lot of different languages that I don't use anymore. Like I was quite good with Haskell, Occam, and other functional programming that I never used professionally. So on one hand, I could have saved some time and learned something useful, but on the other, I think they shaped how I see programming in general and how I think about problems, and they learning about different paradigms kind of gave me broader perspective. So I don't have anything that I would not learn.
You want to continue?
I make Aleksandra's answer the same as mine, because I think like all the stuff that we learn come back to you in a certain way. A couple of years ago, I was this person that every time I heard the word PHP, I was like, I don't want to know anything else about PHP. And I worked with it professionally, but I was like, okay, I don't want to hear that thing again. But the fun thing is, once you the web, and I think Aleksandra had some slides to show this, there seems to be this wheel in the web ecosystem. There seems to be this wheel where concepts where we learned a couple of years ago somehow resurface and are useful again. And I feel like my disdain for PHP back then was not justified, because now, first of all, there are patterns that I use in PHP that came back. There are things that started showing up again. And because I already had this experience with something that I didn't like back then, it's way better. The same thing happened with jQuery. I had a couple of times, I hate jQuery, bloated, whatever. And now, stuff that I learned back then, the history and the essence behind is what helped shape the knowledge that I have today. So I would do everything the same way I did. So that's it.
Johnny, what's your experience?
Sorry, I would definitely not learn CSS. I don't like CSS, and that's pretty much it. Thank you.
Yeah, and I feel the pain about CSS, that's definite. I've been a front-end developer for a majority of my career, but as I can second what Tanya has said, lucky to be in technology. I think that's what I believe. All right, next question from the audience, because we have nothing in Slido, so hands up. Okay, we have a hand up.
Yeah, touching upon the reactivity topic, do you think with how use effect was implemented in React was a design decision from the Facebook team?
That's a great question. Use effect is definitely the most funny thing to talk and disdain nowadays in the React ecosystem. But for instance, there's a great talk by David Khurshid, the creator of Xstate, called You Don't Need Use Effect. I think that's the name. I think React is reactive. I think, and this can get some discussion, but React is reactive. There's no fine-grained reactivity. It's more of a coarse reactivity because you need to re-render and all those things. Use effect had to be done the way that it is because of all the way React works. I've heard discussions, and maybe on the future, React figuring out dependencies on the fly and not needing to have the dependency array on all those things. But when you implement something, I think that's something that's important to take in mind. When you're implementing something as a developer, sometimes the decisions have to be made, and sometimes decisions bite you in the face. In this case, people don't like use effect. Well, now they're trying to work to see what's going to change on the future, but it's there to fix the issue that it is. You need to run side effects in React somehow. So, well, it's a design implementation that had to be because of the way that React is working. And just to do some promotion on that side, Tejas Kumar is going to release a book in March called Fluent React on O'Reilly that goes in the depth on why use effect works the way it works. And it's definitely a great book if you haven't either an O'Reilly subscription on something that's coming out. So just something that came up on top of my mind.
Thanks a lot. Another set of questions to join in on the example of OLX, which parts of it are micro frontends?
All right, so which parts? Mostly the parts that touch most of the features of our jobs categories. So, for example, employer panels and candidate profiles, etc. So these are micro frontends already. Most of our features which are connected to deliveries are also micro frontends, and a service booking panel. So, this sounds like 3 things, but actually there are around 8, maybe 10 micro frontends already. And then why monorepo? Well, that's a long topic to discuss, but specifically for a micro frontends and specifically for module federation implementation, you would want micro frontends because in the end your application is going to be consumed as a monolith. So then you still
Come closer to me so people
Yeah, sure.
in the room can see you. I just remember.
So for this very reason, you absolutely have to be able to test the entire user flow. You have to be able to test your application as if it was a monolith. So then, if you, for example, had 20 micro frontends, which in a different repository, then how would you keep everything in synchronization, like all those 20 repos? You will inevitably have to build another set of tooling that would sync all your repositories whenever you want to start up your application, right? So, and then you will end up with a situation, for example, that there is a button which you do not know where it is. So how do you debug your application, right? So something happens in production. Where do I find this button? Like, I do not have access to this repository. So this would be, if nothing else, this would be the main reason. And then also like regular stuff like sharing your tools, sharing all your scripting, etc. For example, what we have is we have code generators for every micro frontend and for every single library. So you can just check out the monorepo, type a code generator command. It's going to generate a new micro frontend for you, and then like you are all set. You can start committing, etc. But monorepo, like of course, it is going to be in the end a little bit more complex at some points. For example, the pipelines are going to be more complex, and you have to do some work there, and there will be maintenance here.
Yeah. So another question to John. I'm not sure if this is a little bit passive-aggressive or not, but the question is why monorepo?
Why? So I was just answering this why monorepo.
All right, sorry. So moving on. Aleksandra, there's a sort of questions to you as well.
Okay, yeah, so there's feTS for server. Yes, that's right. So basically you can create REST APIs with feTS server, like programmatically, like you define all the endpoints, all the schema. We are currently using Typebox. Previously we were using Zode for validation. Now we replace it with Typebox. And it gives you open API out of the box.
Another one to you about usage of Copilot?
Yeah, I do use Copilot. I mean, I have it turned on most of the time. I like using it, especially for like boilerplate code, and especially at conferences. It helps a lot. But I do not rely on it some of the time. Like sometimes I would really want it to write some code for me, but it can't, or it hallucinates too much and it produces code that doesn't really work. So I think it's great for like, you know, when you have to write a lot of boilerplate, especially for your tests. It can generate it very quickly, and it's usually, you know, it's boilerplate anyway, and it's usually very good. Some other places where I found Copilot useful is working with code mods. It also it deals with it surprisingly well, but a lot of time it would produce some bugs. So just, you know, my tip is to be very careful and not rely on it too much, especially for the code that ends up in production. Because, you know, if you make bugs in your tests, then kind of also some of the code can end up in production. But, you know, it's always a bigger risk if it goes there directly.
Right, Daniel, I think this one is going to you.
None do you use this one? Use both. I'm going to use both. Yeah, that's the best. Okay, so yeah, please read it. It's easy.
Still don't understand why no hydration is better than hydration. If the tree is the same as the one returned from SSR, what are you losing anyway?
So basically when we're doing hydration, what happens is you get the HTML, nothing is interactive, and you need to download all the JavaScript. So everything that you've written on the server needs to be downloaded, so the client. And then what happens is this code is executed, and this code does check your tree and tries to figure out, okay, this is what was in the server, this is what is in the client, this is the event handler that needs to be attached to it. So basically, there's all this extra work that is being done when you're doing hydration. When you're using reasonability, this doesn't happen. Once you get your HTML, it's already interactive. Well, we're going to need to wait for the JavaScript to be loaded, but what happens in Quick, basically they have service workers running on the background that's fetching this JavaScript, so once you click it, you already have it. So there's a lot of optimizations around this. So if you want to learn a bit more about this part, if you pretty much check any Mishko's every talk from the last couple of months around Quick, he has a very good explanation and very good slides on this process. So I definitely recommend you to check this out. But yeah, basically the answer is hydration, you do a bunch of work. Reasonability, you don't.
All right, another question to Johnny. Do you use multiple frameworks with Module Federation or just React?
Just React, and for one simple reason is that, well, the performance. I know that sometimes the performance of our website is another thing. Is it good? Is it bad? I would say that currently we are struggling with it, but if we were to add another framework or set of frameworks on top of what we already have, we would basically kill the application. So I think that the rule of thumb here is that if performance matters to you, so if you are developing a website which is publicly available and you need performance to be good, then just stick with a single framework. If you are developing maybe a business application, so the performance is not that important there because the business users, they are forced to use your application. So even if it's slow, they will use it. And then if, for example, you have many teams within your company or project, so half of them are Angular devs, half of them are React devs, then it's going to save some money in the end, maybe, if you use two frameworks. But yeah, rule of thumb, just use one framework. Just because we can doesn't mean that we should in the end.
Another one to you. NX or any other open source tooling, do you use it for managing the monorepo?
Right, so I actually wanted to mention this during the presentation, but I kind of forgot. So whenever we are talking about monorepo, what I literally mean just a single repository with multiple projects or projects in it. We currently do not use any other like TurboRepo, NX or something like this because simply in Module Federation they offer little to no advantages. We will probably at some point have to use something to manage our dependencies, for example, but currently not yet. So most of the work that we have been doing is around pipelines and to make sure that we run the jobs that we need to run whenever there are changes in specific places of the repository, and that's pretty much that's the bulk of it.
Just to add on that, we're using NX on Automoto. Yeah. So Automoto, we have a monorepo. We don't have micro frontends there, and right now we are using NX to help manage that part. So on another business unit, here part, as you can see, OLX has a bunch of stuff. We managed to have micro frontends on one part and monorepo and with NX on another one. So just to add on that.
All right, last two questions and we're wrapping up. But Aleksandra, great question to you because I'm also experimenting with Arc. So how is your journey with Arc so far?
Yes, I absolutely love it. I was very skeptical at first, then I downloaded it and I was even more skeptical and I couldn't get used to it. But now I absolutely love it. It took me like 1 week to get used to this model. It's great. The developer experience is great, like all the little interactions. The thing that you can have like multiple workspaces you can switch between. So I have like, for example, my personal workspace and I can have some websites pinned there or like other tabs done I want to have in my workspace. And it's just great. And the fact that there are just boosts, you can customize websites. I don't really use it, but I know that some people are, and they also really love it. And it all works so smoothly. And why not Chrome? Because Arc is like, it has everything that Chrome does. It's the same developer tools and the same extensions. Like everything works exactly as it's a Chromium browser. Everything works exactly the same, but it's just nicer and better and prettier. So if you need invites, I'm not sure if this is still invite only, but I can send you.
It's open at the moment.
Oh, okay,
yeah,
perfect.
So definitely recommend
So
it.
go and download.
All right, so last question to Daniel in 3 words. What do you think about new Flash movie?
In 3 words? I was ready to start a new thing very quick, right? So I cannot do this in 3 words, but I can say like, if it's adapting one of the best comic book stories, it kind of made a good impression, but it was already done by the TV show, so it didn't have as much of impact. Then you had other controversies associated to it. If you don't know anything about The Flash, you should definitely watch it. It's still a good movie. It's not great, but it's still a good movie. But there's also this superhero fatigue, and I'm not going to stop here. So if you have more questions, you can ask me after.
All right, clear. So I've asked everybody to do a lot of clapping today, and I will ask you to do clapping one more time, but I want to name for who this clapping is going to be. So first of all, our speakers. Also, before we start clapping, yourself here online, really appreciate you being here, and thanks for joining the event. And also everybody who made this event possible, your faces around that did a lot of work in order for you guys to be able to come here and enjoy this event. So one last time, big applause.